Alright, let's go to the next topic, temperature of ocean waters. So here it says the temperature of oceans depends upon spatial and vertical variation. That means the temperature of oceans depend upon the depth of the ocean and the location where a particular ocean exists, meaning horizontally. Now another well-known fact is that ocean waters get heated up by the solar energy. Even land gets heated up by the sun's energy. The only difference is that land heats faster than water, but water loses heat slower than land. That means the process of heating and cooling of the ocean water is slower than land. Now let's look into the factors affecting temperature distribution of ocean water. The first one is latitude. We know that as we move away from the equator towards the poles, temperature drops. And the reason is due to the incoming solar energy. Sun's energy is more direct at the equator, and that's why the vertical rays of the sun gets concentrated on a smaller area, making the equatorial region hot. And as we go away from the equator, at the higher latitudes, the angle of the sun rays are oblique. As a result, slanting rays have to heat a larger area, because of which the slanting rays of the sun are not very hot, making the higher latitude regions cold. So with latitude, the temperature of the ocean water changes. At the equatorial region, the ocean water is warm, and as we go away from the equator towards the poles, the temperature of the ocean water decreases. The second factor affecting temperature distribution of ocean water is unequal distribution of land and water. In the previous point, we saw that land and water heats up at a different rate. Land heats faster than water, and land also loses heat faster than water. Now if you look at the world map, the northern hemisphere has more landmass compared to the southern hemisphere. That means the oceans in the northern hemisphere has contact with larger extent of land than the oceans in the southern hemisphere. Hence the oceans in the northern hemisphere receives more heat due to the contact with the larger extent of landmass. The third factor is prevailing winds. Let me first quickly tell you what are prevailing winds. So winds are part of Earth's atmospheric circulation. And you must be aware of this picture. We have the easterlies and westerlies, then we have the trade winds. So all these winds, they continuously blow from a single general direction towards a particular point on the Earth's surface. Now that you know what are prevailing winds, one more thing that you need to understand is that these prevailing winds blow from the land towards the ocean and vice versa. That's why they are also called as sea and land breezes. So what happens is, as the temperature of the surface of the land rises, the land heats the air above it. Since the warm air is less dense, therefore it rises. On the other hand, water surface heats slowly. As a result, the cool air above the sea rushes towards the land to fill in the gap that is created by the warm air on the land. All of this happens during daytime. At night, the reverse happens. Land loses heat faster than water. As a result, the air above the sea is warm, so it rises, and the cool air above the land flows towards the sea to fill in the gap that is created by the warm air of the sea. Now this is called land breeze, and this one takes place during night time. So the winds blowing from the land towards the ocean drive the warm surface water away from the coast, making way for the deep cold water to rise from below. Now this entire process causes longitudinal variation in the temperature. And the opposite of this would be during daytime, when the cool air from the sea flows towards the land, it piles up warm water near the coast. So this kind of temperature variation is caused due to prevailing winds. And the fourth factor affecting the temperature distribution of ocean water is ocean currents. Have a look at this picture. The red arrows are the warm ocean currents and the blue ones are the cold. And if you see, most of the red arrows, that is warm ocean currents, they originate at the equatorial region. And the reason is simply because the equatorial region receives direct sunlight all throughout the year, and that warms up the ocean water at equatorial region. If you look at this picture again, the red arrows, that is the warm ocean currents, are moving towards the polar region in both northern and southern hemisphere. Similarly, the blue arrows, that is the cold ocean currents, they are moving towards the equatorial region, which is warm. That means the warm ocean currents raise the temperature in cold areas, while the cold ocean currents decreases the temperature in warm ocean areas. Now here it says Gulf Stream raises the temperature. Here is the Gulf Stream. It raises the temperature near the eastern coast of North America and the west coast of Europe. while the Labrador Current, here is Labrador Current, it lowers the temperature near the northeast coast of North America. So these were the 4 factors that influences the temperature of ocean water. Now we are going to read about horizontal and vertical distribution of temperature. If this is a water body, horizontal distribution of temperature means this way, and vertical distribution of temperature means this way. And we also know that temperature decreases as the depth increases. Suppose if you jump into an ocean, there's a boundary between the surface water of the ocean and the deeper layers where you will actually feel the temperature of the water falling tremendously. And that boundary usually begins around 100 to 400 meters below the sea level. This boundary region from where there is a rapid decrease of temperature is called the thermocline. About 90% of the total volume of water is found below the thermocline in the deep ocean. And that is true if you see, because most of the oceans are thousands meters deep. At some places on Earth, places like the Arctic and Antarctic region, the temperature of the ocean water below the thermocline goes up to 0 degrees Celsius. The temperature structure of oceans over middle latitude, so middle latitude is this region, and low latitude is this region, can be described as a 3-layer system from surface to the bottom. I think we already have a picture over here. Look at figure 13.3. On the x-axis, we have the increasing temperature of the water body, and on y-axis, we have the increasing depth of the water body. The first layer, which is the top layer of the ocean water, is about 500 meters thick, and the temperature of this layer is somewhere between 20 and 25 degrees Celsius. Now at the tropical region or at the equatorial region, we know that it is warm throughout the year because the equator receives direct rays of the sun all throughout the year, because of which the top layer of the oceans at the equatorial region has a temperature range between 20 and 25 degrees Celsius throughout the year. But in the middle latitude region, the same temperature develops only during summer. If you remember this picture, during the summer solstice, the northern hemisphere is a little tilted towards the sun, because of which the northern hemisphere receives more sun rays compared to southern hemisphere. So this is when the mid-latitude of the northern hemisphere will have summer season. And it is also during this time the temperature of the top layer of the ocean water at the middle latitude region of northern hemisphere will be between 20 and 25 degrees Celsius. Similarly, during winter solstice, the northern hemisphere is tilted away from the sun, making the southern hemisphere exposed more to the sun rays. And it is also during this time the temperature of the top layer of the ocean water at the mid-latitude region of southern hemisphere will be between 20 and 25 degrees Celsius. Let's go to the second layer of the ocean water. Now this layer is also called as thermocline layer. It is 500 to 1000 meters thick, and in this layer there's a rapid decrease in temperature with increasing depth. That means from 500 meters till about 1000 meters, temperature drops drastically. So always remember, the second layer of the ocean water is called thermocline. Coming to the third layer, obviously it has to be beyond 1000 meters and extends up to the deep ocean floor. So these were the 3 layers of ocean water from surface to the bottom. Now if you go to the Arctic and Antarctic Circle, these are polar region. Here the surface water temperature is close to 0 degrees Celsius. That means the top layer of the ocean water in polar region is frozen. That's why in polar region, countries like Russia, Canada use an icebreaker ship to navigate through the northern sea route, which lies entirely in Arctic waters. So these are special type of ships which are designed to break the ice and make way in extremely cold climatic regions. So basically in polar region, the surface water is almost frozen and there's only one layer of cold water and there is no 3 layers that we saw moments back. The average temperature of surface water of the ocean is about 27 degrees Celsius, and it gradually decreases from the equator towards the poles, because we know the temperature drops as we move away from the equator. Now how much does the temperature drops? It is generally 0.5 degrees Celsius per latitude. That means for every latitude, the temperature drops by half a degree Celsius. So here it says, the average temperature is around 22 degrees Celsius at 20 degree latitudes and 14 degrees Celsius at 40 degree latitudes and 0 degrees Celsius near poles. You can pretty much get an idea that as we move away from the equator, the temperature of the surface of the ocean water drops tremendously. However, The oceans in the northern hemisphere have higher temperature when compared to the oceans in the southern hemisphere. And the reason behind that is because of the distribution of landmass. Now, land areas are distributed predominantly in the northern hemisphere. And we also know that land gets heated much faster than water. Now, that has a relative impact on the surrounding ocean water. Now, here it says the average annual temperature for the northern and southern hemisphere are around 19 degrees Celsius and 16 degrees Celsius respectively. You see, there's a little variation in the temperature of the oceans in northern and southern hemisphere. Even if you look at this figure 13.4, in this picture we can see the spatial pattern of surface temperature of the ocean. Let me quickly draw the equator line. You see, at equator, the temperature of the ocean water is pretty warm. But then as we move away from the equator, the temperature drops. But you see these regions where it shows 25 degrees and 28 degrees Celsius. So here the temperature is a little high because of the existence of nearby landmass. And it is only high in the northern hemisphere because we know that the land masses are more in the northern hemisphere. Whereas if you look at the southern hemisphere, you will not find 28 degrees Celsius anywhere. Therefore, we conclude by saying that the highest temperature is not recorded at the equator, but slightly towards north of it. Now let's get to know about the salinity of ocean waters. Now, what is the meaning of salinity? It means salt. The amount of dissolved salt in a water is defined as salinity. It is calculated as the amount of salt in grams dissolved in 1000 gram, that is 1 kg of seawater. And we know that the seawater is salty. That means salinity is an important property of seawater. Now let's look at the factors affecting ocean salinity, meaning what are the ways in which the saltiness of ocean water is affected. The first one is evaporation and precipitation. Now we know what is evaporation, right? It is the process through which water molecules turn into water vapor with the help of heat. Evaporation can only take away water volume, not salt content. And there is also strong wind that moves over the ocean. So this wind is usually hot, and hot air around the ocean will cause most of the water to evaporate. However, the salt does not evaporate with the water. This will make the salt concentration to remain high in the rest of the ocean water. A very sunny weather can make the evaporation process faster, leaving even more salty ocean water. So the point to remember is evaporation increases salinity of the ocean water. Now coming to precipitation. Precipitation means rainfall and snowfall. Now precipitation can decrease the level of salinity in the ocean. Heavy rainfall often takes place around the oceans. The rainwater are fresh water with small quantity of salt. Therefore the ocean will experience less salinity as there is a huge amount of fresh water mixed with it. Similarly, when snowfall occurs in cold areas, the melting of snow and glaciers creates a pool of fresh water that forms river channels and finally drains into a sea. Now rivers can reduce the salt concentration of an ocean. If there are numerous rivers flowing into a specific ocean water, then there is less chance for high salinity. This river contains a huge amount of fresh water. It is enough to cause the saltiness of the ocean to decline. So the point to remember is precipitation decreases salinity of ocean water. Coming to the second point, surface salinity is greatly influenced in coastal regions by the fresh water flow from rivers and in polar region by the processes of freezing and thawing of ice. I just told you that rivers contain a huge amount of fresh water. It is enough to cause the saltiness of the ocean to decline. So just refer to that point and you will understand. The third point is wind. Now wind is one of the important factors that determine how ocean currents will work. The wind over an ocean water will likely move the surface water. The surface water is usually warm due to the heat from the sun. And we know that warm water is less dense and therefore it moves with the wind, making the cold water to rise from below. Now cold water often contains more salt than warm water. This process of mixing may cause the salinity to decrease or increase. The fourth point is ocean currents. Ocean currents are responsible in both increasing as well as decreasing of salinity. They are able to cause denser water to move downwards and allow the less dense water to rise. That would mean less salinity on the water surface, because cold water is dense and it contains more salt. But as time progresses, the salt concentration will add up and the process starts all over again. And also temperature influences the salinity of ocean water. high temperature of the water will make the space between the water molecules to be more further apart. So what that means is warm ocean water tends to become less dense. Now water that is not dense means it contains less salt. On the other hand, cold water often contains more salt. So any change in the temperature density influences the salinity of ocean water. So these are the 4 factors that affect the ocean's salinity. Apart from these 4 factors, there are a few more. I'm going to make a separate video later on in which I will explain all the possible factors that affects ocean's salinity. Now let's quickly get to know the horizontal distribution of salinity. Before we start this topic, I want you to go back and revisit the previous topic again. You'll need it. Alright, let's quickly finish this topic. In the previous topic, we saw that evaporation increases the salinity of ocean water. And on the other hand, precipitation reduces the salinity of ocean water. Because precipitation is rainfall and rainfall is fresh water. So when fresh water is added to ocean, it reduces the salinity. With this much of information, we understand that in humid region, precipitation exceeds evaporation. And in arid and semi-arid area, evaporation exceeds precipitation. Now let's have a look at the world map. So this is the tropical region or the equatorial region. Then we have the subtropical, then we have temperate, and finally we have the polar region. Now tropical region receive the maximum amount of sunlight throughout the year. But it is very humid in tropical region. The salinity is relatively lower in the equatorial region despite the higher temperature. This is due to the simple reason that the heavy equatorial precipitation dilutes the surface waters and evaporation is less due to cloudiness in the region. And also if you see, numerous large river drains into the ocean of the equatorial region, bringing in large quantity of fresh water. Now let's go to the subtropical region. Now here the precipitation is low and the rate of evaporation is high. Plus the subtropical region is a high pressure zone where the air descends. When the air descends, rainfall is absolutely negligible. And due to clear sky, the rate of evaporation is high. That's why you will find most of the deserts of the world in subtropical region. When evaporation exceeds precipitation, the fresh water evaporates, leaving behind salt. The belt of high salinity is found between 20 and 30 degrees north and south of the equator. Now let's go to the polar region. The temperature here is low throughout the year, so the rate of evaporation is also very low. In addition, at certain seasons, fresh water is supplied by the melting of snow and ice lying in thick layers of the ground. Naturally, the surface salinity of the seawater in this region is relatively low. So overall, to find out the horizontal distribution of salinity, you simply have to keep in mind few points. The place where evaporation is more, there the salinity of the surface water will be high. And the place where precipitation is more, fresh water will decrease the ocean salinity. Because freshwater sources are rainfall and melting of ice and glaciers. Now with this much of information, you simply have to look for the regions where you will find these conditions. The equatorial region receives more rainfall despite having high temperature. In subtropical region, the skies are clear and precipitation is low. So the salinity level will be high. And in the polar areas experience very little evaporation and receive large amounts of fresh water from the melting of ice. This leads to low levels of salinity. Let's look at the Indian Ocean. The low salinity trend is observed in the Bay of Bengal due to influx of river water by the river Ganga. And if you see, almost most of the rivers in India drain into the Bay of Bengal. On the other hand, the Arabian Sea shows higher salinity due to high evaporation and low influx of fresh water. Now let's look at the last topic of this chapter, vertical distribution of salinity. By vertical distribution, we mean changes with respect to the depth of the ocean. So salinity of the ocean changes with the depth. Now at the surface, we know that salinity increases due to evaporation and decreases by the input of fresh water from river, ice and rainfall. But as we go deeper in the ocean, salinity is very much fixed because there is no way the water is lost or any more salt is added. Salinity generally increases with depth, and there is a distinct zone called the halocline, just like we have thermocline if you remember. Thermocline is the point from where the temperature drops drastically. Similarly, from halocline, salinity increases rapidly. And always remember this point, cold dense water contains more salt. And that's how you can remember that as we go deep in the ocean, temperature drops and salinity increases. So with this, we have come to an end of this chapter. All the illustrations and maps are available on the Instagram account of this channel. The link is there in the description. You can also find the question and answer on the website. Again, the link of that is also available in the description. I hope you found this video informative, and if you like this video, let me know your thoughts in the comment section. Thanks for watching, and I'll see you in the next one.